Hi my friends, today we model this part. It has a name and the name is stylish handle. The drawing is here. You think this part is easy to model? No, it is not. It has some tricky aspects. We take care of this slot. Radius 45, distance 60, angle 75 degrees. And this dimension, radius 32. If you add 32 to 45, you find radius 77. Here is the same 77. And the part has cuts. It is not finished here. But you see in this section we have radius 22 when the total dimension is 44. This means that we start with this slot and another one, external one, offsetted on 32. Let's start. New standard millimeters IPT, XY plane, and we select slot center to center. Start from here with a line of 60, tab 75, and the diameter is 45 multiplied by 2. This is the first slot. Then we apply offset at 32. Finish sketch, extrude this contour symmetrical on 44. Then we apply radius 22 fillet on both sides. Okay. Now, if you take a look to the drawing, you see we have to create 3 cuts. One is here, another is this one, and another at the bottom. The first one is this, radius 90. The other one is at a distance of 55 from this center, not this center. This is the center point of the part. And the third cut is this, radius 50, radius 65, distance 42. This line is tangent with this arc being horizontal. Okay, let's do this. We select the plane XY again, F7, home. Now we project some entities, this 3 and this one. We start by creating an arc from this point to somewhere here, and the radius 90. we draw a horizontal line from this very point to the right, and we go down to this arc on vertical. I hope this is vertical. Yes, you see up the mark perpendicular. Dimensions, we start with this constraint. This dimension is 55, and this point is on the same vertical with the center of this arc, or this arc. We have to place it on the same vertical. Now it is not vertical. You see here the projection of that arc. So we apply vertical between these 2 points. Good. One dimension needed. What is that dimension? Let's see by applying some movements. You see in the drawing that 66, yes, from the center of the upper arc of the slot. Dimension from this point to this line of 66. Now we have a fully constrained sketch. We have now these 2 areas, but I have to project this. Yes. Now we have an area here and the other up. The other cut is based on an arc with a radius 50, and we continue with another arc by using our specific procedure. I apply line, I keep pressed the left button, and I obtain an arc, my friends. You see, I go to somewhere and then outside on a horizontal. I trim this end, I place the constraint tangent, I place the dimension of 65, and that distance of 42, this one. 3 dimensions needed. One of them is the distance between this point and the center point, 42. The other 2 are distances on vertical and on horizontal between these 2 points. They are coincident, so we find the fully constrained sketch if we place them coincident. You see here, fully constrained. Good. Now I apply finish sketch and extrude. What to extrude? This area, and the bottom area. Symmetrical with cut all the way through the part. Okay. You see that 3 cuts. Now we have to conserve this contour by creating a sketch and getting out. I make it not visible, and we'll use this sketch in the future. We continue by creating a work plane coincident with this face, plane, face, to the right, and 0. Now they are identical. We'll use this plane. We continue by creating a plane on this face. We place it here at a distance of 0. Good. Then we create a new plane based on this and this point. This last plane is the base for a new sketch. F7. We project this arc, this line. I need this line. This is not necessary. And we also project this and the two sides. This is not necessary, neither this, and we apply construction for them. We have now two areas, and we'll select this one. Why? Because we create an extrusion. Extrude this area, not this one, to this plane. Okay. I hide this plane and I use this for a new sketch. F7, I project. F7 is not necessary because we have lines and arcs in the face. Project geometry. I project this line, this arc, and this line. The same to the right. Finish sketch. Extrude this close contour and this close contour to the part. Okay. I hide this plane and we have a nice object. Now we use a new procedure. In fact, we use the tool delete face to cut this face. And if we do this, take a look what happens. It happens that the solid is not solid, but a number of surfaces. Yes? Here you can see the components of this initially solid. Good. We create a new plane based on this line and this line. They define a plane, yes? Then I make visible this sketch and I create a new sketch. I project some entities from the former sketch, and these entities are this to create a close contour. Then I hide the sketch and I keep this finished sketch. I don't need a plane, and I apply patch to create a surface from lines with a close contour. This is the patch. Okay. Now this surface is separated from the others. To include it in the part, we use the tool stitch. We want to stitch this face with the other. I select the surface, I select the part, and I change the tolerance because this is huge. I put here the minimum tolerance, 4 zeros and 1. You'll see why. Apply. Done. Then we use again delete face to eliminate all these 4 surfaces. Okay. Good. If you take a look at the part, you see that it is a sheet metal part with the thickness of 3 millimeters. To apply this thickness, we use the tool thicken offset. We select the kilt. This is the only kilt we have here. That all surfaces are connected with the so-called stitch tool. We use this option, direction to the interior, and the value of thickness of 3 millimeters. Okay. Even if I place there the minimum tolerance, we still have this message, and we must accept it. This is the limit of the possibilities with the Inventor. You see how this looks. Now we go back to the drawing and we see that there is a fillet here of 1, another is here also 1, and 4 millimeters both sides, and this is also on both sides. And this, we select an edge and all other to have a continuity. Plus, I select also this. Plus, this is also 1 plus 4 to be applied on these 2 edges. Very good. The last action is to apply this to cuts on this face. Dimensions are here: 16, 100, 16, diameter of 10, radius 8, radius 5. We select the face to create a new sketch. We place a circle with diameter of 10, then another circle with radius of 8, another circle with the radius of 5. We draw lines. I keep pressed the left button and I have a tangent, and then a vertical. Same here. I keep pressed the left button, I have a tangent, I place a vertical line or parallel with the other. They are equal, and this solves the symmetry. Trim this and this. Dimensions are maintained. Then I place on the same vertical one of these two centers aligned with a center point, and also this with the center point. Dimensions, this is 16, then 100, then again 16 between the two arcs. Finish sketch, extrude, 1, 2 closed areas, 2, and I select this face, internal face. Okay, now we have finished the part. Let's see what is the volume. Properties, physical, update, copy. You know, I make the drawings, my friends, and I can make mistakes even here or to the original. Paste. The difference is very small, so we accept the new value, and all of us know that this is the result of what we did here. Maybe I was wrong before. Material is stainless steel. And view has default lights. Visual style is shaded. We can compare the two parts. Oh, I place here also fillet, but this is not in the drawing. The drawing has a fillet only here, not up. You can choose any other solution. That's all for today. Thanks for watching. Bye bye.